all of you guys how you felt in terms of the homework. How was that? Just type in chat.
I
So,
did some of it, but I don't know how to turn it in.
oh yeah. Oh, we can cover that today, I think.
Yeah,
But
I can actually show you guys right now how to turn it in. So I'll screen share real quick. Um, yeah, right here. So do you guys see my,
Well, I did some.
are you guys able to see my screen? Okay. Yeah, I think so. So if you head over to the Google Classroom, right, you should be able to head over to classwork here. And then for week one homework, um, well, I think the submission closed for this one, but for week two homework, I think you can go here, view instructions, and oh, maybe you can't submit it. Maybe I need to make a due date for this. Let's just say it's due next week. Okay. I think you should be able to submit it now. I know two people last week submitted it, but okay. I'll get back to you guys if I figure that out. All right, but Mohan, do you want to get us started on today's content?
yeah, I can do that. Let's see. All right, once again, wait, can I share my screen?
Yes, I believe you can.
So, okay. So once again, we're just going to search up Google Colab, Google. And then just make sure you're on the right account, whatever account you want to use for Met Excellence and stuff. You can just make a new notebook. I already have one here, so I'll just use that one. And if you guys want as well, you can rename it just to make sure that you don't like lose it or just for like personal like organizational preferences. So I'm just gonna name this week two Met. And so, yeah, let me just get a thumbs up once you guys are in, or if you guys need help, just let me know, and I'll just go through those steps again. All right, cool. I just wanted to start off by reviewing the int or the no, reviewing the input sort of aspect of Python because we covered that really briefly, as you guys remember, before we had to end the class. But yeah, I'll just kind of show you guys that. Okay, let's actually start off with like a review on functions, right? One of our functions being print. Remember, we have print, it's the keyword, and then we have it in the braces. We're gonna put whatever we want in these parentheses here. And remember, we can either do a number, right, called an integer or a float as like 12, or we could do 12.3. Those are both numbers, or this one here is a float. We can also turn this into a string by adding these double quotes. You can also use single quotes if you want, but I'm going to be using double quotes for today. And remember, another data type that we learned was the booleans. Booleans come in two flavors, true or false, right? And yeah, I think those are the only ones that we covered yesterday or last week. So let's say I wanted to print hello world. I would have to use those quotation marks. Uh, I am not able to do this because uh, it's going to be confused on Python is going to be confused on whether it's a variable or not or whatever's going on here. So we have to make sure that we add those quotation marks. Let's see. So, and then also for Colab, if you want to run like a particular section of code, you're gonna have to hit the YouTube play button in the corner here. And the first time you run it, it's gonna take a while, but every subsequent every run after that one is going to be a little bit quicker because um, Google's trying to find a place to run your code on their servers, so that's why it takes a while for the first time. If you want to make one of these blocks again, you're gonna hit the code button, the plus code button at the top, and it's gonna make another one of these squares here. And you can also run that there just to make sure that they're like separate so you don't have to run the whole thing at the same time. Remember, that was one of the differences between an uh an IDE on the computer versus something outside, right? Let's see. We wanted to cover input, right? So let's kind of review variables, right? Variables are like buckets, right? Buckets with names. Let's say I wanted to fill my bucket with apples. I'm going to name my variable bucket. Okay. And we're filling this bucket with 12 apples, right? And then let's say I wanted to use this bucket somewhere else. I'm running it so the computer knows that this bucket is a variable. If I wanted to run it in a separate sort of code section, right? This bucket is equal to 12 apples. If I wanted to check what was in my bucket, I could say print bucket. And one thing I want you guys to realize is I didn't put these in quotations like this because if I did, it would just print the word bucket. If I don't include that, that way it knows it's a variable and it's going to be able to reference or kind of get the information from this previous variable here. So it's going to check the bucket. It's going to be like, I know what bucket is. Bucket is 12 apples or um, the string 12 apples, right? And so that's how it ends up printing it out. Let's see. Um, we should cover We should cover arithmetic operators in a little more depth. We had the conversation about we can do your math homework on Python, so you don't have to do it. But we have to cover a few more things in terms of what exactly Python can do for your math, or like the limits of that. Um, you can type 1 plus 2, right? And you can run it, and then it's gonna shoot out a 3. An interesting aspect of Google Colab is you don't have to print out every single thing here, you can just kind of write 1 plus 2 and it's going to print it out. You don't have to put it in the print statement because it's looking for sort of returns, right? And 1 plus 2 here is just it's just a unique feature of Google Colab. I think that's all you guys need to know about that. Let's see. We can also do 1 minus 2, right? We can do 1 minus 2. In this scenario, we're going to put it inside of a print statement here. We're going to do print 1 minus 2 and it's going to give us with the negative number, -1, right? Print 1 minus 2, -1.
Why do I need a print?
You don't need to. Let's say you're running it
Oh,
on like your computer, right? In that case, you would have to use the print statement. But if you wanted to that's one like good aspect of Google Colab is when you're testing really quickly, you don't really need to use the print statement all the time. But typically, it's good practice. If you don't use it when you're using Google Colab, it's not going to hurt anybody. But when you're going to use it, or like when you don't use it, in another sort of IDE. Remember, that stands for Integrated Development Editor. Or no, Integrated Development Editor, something like that.
It's an
But
integrated development environment.
environment.
Yeah.
Okay, good catch. But Yeah, so it doesn't hurt anybody, but when you want to use it somewhere else, when you want to run this code somewhere else, that's where we might run into a bit of an issue. Does that answer your question?
Yeah.
Okay, perfect. We can also multiply these numbers. We're not going to use the X here. We're gonna have to use this asterisk symbol here. It's if you're on like a computer, it's right above your like 8. So you have to hit shift and then 8 to access this symbol here. But then we can get our 8. It's not going to run with 2x4 because that doesn't really mean anything to the computer because typically you will use the symbol X for variables. And so, yeah, you'd have to use this symbol here. That's just kind of how Python works. Let's see. Um, we can also divide numbers, right? We can do 2 divided by 4, right? That's going to give us 0.5. Can do 3 divided by 4. That's going to give us 0.75. In yeah, that's pretty much it. And then modulus. That's going to be the percentage sign. So this here, I think I'll keep this on the screen because I think it's a bit important. Modulus. What it does is, okay, let's find another good example. Okay, so what this does is it's kind of like a remainder in math. So let's say I was trying to do 6 divided by 3, right? That would be 2, and there wouldn't be any remainder, right? So since there isn't any remainder, I'm getting the value 0. Let's say we did 7, which obviously doesn't go into 3, or like 3, there's going to be a remainder when we do 7 divided by 3. So it's going to give us a 1 here, right? Because when we do 6 divided by 3, that's going to be 0, but since there's 1 extra, there's going to be an extra remainder. Once again, if I did 8, for example, what's up?
Wait, so you don't use the slash when you're using um division?
So, yeah, so this is a little bit different from this is a little bit different from division, right? This here gives us the entire number, right? 2 and then 66666 and so on. But when we do the percentage symbol instead of just the dividing, right? It's going to give us what would be remaining if it went into it equally. I feel like if that makes sense.
Oh, okay.
Yeah.
Yeah, basically
That's
the
called a
percent
modulus?
symbol. Yeah, it's called the modulus operator. It's the same thing as a mod in math. It just returns the remainder. So it just
Okay.
returns the remainder of 8 when divided by 3, right? 8 is 2 remainder 3 or 2 remainder 2. 8 divided by 3 is 2 remainder 2. So, yeah.
Okay. Got another one here. And then kind of like the exact opposite of this is something called floor division, where we do print and then 8 and then 2 slashes instead of just one. That's going to give us, once again, not a very good example. Do 9. No, we're going to do 10. Okay, so 10 and then if you do 2 slashes here, that's going to give you, wait, let's see. Okay, let's say we did 10 divided by 3, right? That's going to give us 3 and then like a going on remainder. This is says 0.333, so that's like a remainder of 1. If you do 2 of these, that's going to give us 3, meaning it got like rid of the remainder part. That also just kind of another way to kind of express that is it just took away or like it took the number and brought it down to like an integer, if that makes sense. So like by taking away all of those decimals, it turned it into an integer. And yeah, I think yeah, pretty much it just kind of took the decimal and brought it down to the closest integer, like underneath it. That's kind of what floor division means. And then so here, this is 8 slash 3. That's going to give us 2 because 6 6 divided by 3 is like the closest integer or the closest number that doesn't have a decimal to 8. So that's another way of thinking about floor division. And let's see. The one last arithmetic operator or one last kind of like math sort of calculation I wanted to cover was the something called exponentiation, which just kind of means making an exponent. If you guys are familiar, like 2 times 2 times 2, these three numbers are being multiplied, and there's three of them. So we can kind of express that as 2 to the power of 3. 2 to the power of 3 just means there's three twos. Each of those twos is being multiplied with one another. So 2 to the power of 3 is the same thing as 2 times 2 times 2, right? And that can be written with two asterisks instead of one, right? One mistake, you don't want to just have one. When you want to exponentiate or when you want to when you want to multiply repeatedly, you're gonna have to include two of those. It's important. And let me just 2 times 2 times 2. They're both gonna be the same number. And yeah, those are our Python arithmetic operators. We did addition and subtraction, multiplication with the asterisk. We did division with the forward slash. We did modulus using the percentage here. We did exponentiation with not one, but two asterisks. And we did floor division with two slashes. Yeah. Okay. Uh, should I cover assignment operators?
Yeah, sure.
Okay. All right. So let's see. Is that on the homework? Okay. All right. Now that we just covered the math, I'll loop back to inputs real quick. Remember, if we have our bucket, we're gonna say int input, and then we're gonna say how many apples you got. Okay, so this input's gonna take in obviously an input from the user. So that just means I'm able to type it in and send it to the computer. And then this int here just kind of lets the computer know that, hey, whatever this user says, I want it to turn into an integer instead of a string, right? So let's see. If I said, how many apples do you got? I'm gonna say 12, right? And then I hit enter and it didn't tell me anything. Do you guys know why it didn't ty like respond with anything afterwards? It's because we need to print out the value. Okay. So I saved whatever input I got. I turned it into an integer. I turned it into a number. I'm putting it in my variable called bucket. And now I'm putting it in a print statement here. So now if I type 12, it's gonna tell me you have 12 apples, right? Uh, a cool little feature of Python is you can concatenate, meaning you can join two like different types of variables together to kind of make like a new word, right? So if I said 12 here, maybe not. Let's see. I have to turn this back into a string. Cool. So this only applies to strings once again. Uh, if both of your values are strings, that means you're able to add them together or like connect them together, right? As you guys can see here, this int here is kind of the opposite of this string here, right? This bucket is being converted from that string or like from that integer because we turned it into an int using this int. We're turning it back from an integer back into a string. This is just to kind of show you that you can kind of turn any variable into whatever format you can with reasonable limits, of course. But see, now this is a string here. And since it's a string, we can connect these two strings because This apples here is also a string, and this string with a number is also going to be a string, and that's why it prints out 12 apples. Let's see, probably do this again. If I wanted to print, right, just a regular word, hello, and then that's uh it's going to combine these two together. And one thing you guys will encounter is if you don't add a space between one of these, it's going to combine it together without a space. So you need to make sure that you provide that as well. Yep. And also, if you wanted to, the reason like making it into an int is important is because let's say you wanted to, let's say you already have like a few apples in your bucket, right? So you did bucket plus, well, because you okay, no, never mind. Let's say you're adding 12 apples to your pre-existing bucket, right? You can say I already have 6 apples in my bucket. You can add numbers together like that. Whereas if we didn't add this int, there would be an issue because um, as of right now, Python thinks the variable bucket is a string. And as we saw in the previous example, you can't really add strings to integers unless you make one or the other a uh, string, right? So if I turn this into string, however, right? This is here. It's gonna kind of add them together, remember? Because since bucket is a string and then the number 12 isn't really a number, it's the string 12, right? Just like how we saw here with the hello met, it's gonna add these two strings together and it's gonna combine them. So even though we added 12 apples together, we're gonna get a much larger seeming number. So that's something to look out for. Make sure you change your variables into the kind of data type you want them to be. That's really important. Let's see. Hmm. Yeah. Uh, I'll cover comparison operators now. Uh, that's a good example. So the first comparison operator we will cover is the is equal to. If you guys remember, Booleans come in two flavors, true and false, right? So what this does is comparison operators will tend to return one of these Booleans, either being true or false, right? So so this is just kind of asking like a question, right? Is 2 equal to 3? 2 is obviously not equal to 3, so it's going to return false, right? Okay. This one here is another comparison operator, which is called not equal to. For this comparison operator, it consists of a exclamation mark, an exclamation mark, as well as a equal to sign. Combining these two just kind of makes it not equal to. So it's going to compare both sides. Is 2 not equal to 3? 2 is obviously not equal to 3. So we're going to get a true for that statement. Can I get a show of hands if you guys are familiar with greater than and less than symbols? Kind of from school. Give a chat.
Yeah.
Okay, cool. So yeah, I'll just cover those really quickly. They kind of just look like uh kind of like L shapes like this. Whichever side it's facing
Hi.
is just kind of to say whichever number is larger. What's up? Okay. So whichever number or whichever like the open side is facing kind of indicates whichever number is supposed to be larger. So this would just mean 2 is greater than 3, which obviously is a false statement. So it's going to return false. The same thing here. 2 is less, or a different kind of variation. True is less than 3. 2 is obviously less than 3, so this is going to be true. This this one here is very similar to the previous one, except it also includes the value it's considering, right? So is 2 greater than or equal to 3? Uh 2 is not greater than or equal to 3. So this is going to be false. And then this one here, 2 is either less than or equal to 3. It is less than 3. I mean, it's not equal to 3, but it is less than 3. And so this is going to give us true. Now let's see what happens. False, true, false, true, false, true. Okay, cool. So that's just kind of a brief overview of comparison operators. This is used to typically compare two numbers together. We will kind of in the future use it to compare strings as well. But right now, we're just using it to compare numbers. And yeah, I can uh, I can cover chaining them together as well. So we can also, what does number two with, okay, so this here just means not equal to, right? These two here mean equal to, and then since there's an exclamation mark and equal, that just means not equal to. So that's just kind of like a syntax thing. That's how Python kind of takes a look at like, hey, are these numbers, what does that mean? That's just what Python kind of will explain. Yeah, not equal to. Okay, so for Python logical operators, it's kind of like combining these together, right? So let's say I wanted to compare the value x. Let's see. Okay, I'm gonna compare spring break, spring break, true, and then summer break. Okay, yeah. So spring break is true right now, uh, for the Wayzata School District, and then summer break is false. So let's see. You can whatever this kind of returns, right? Remember how 2 equals 3 is going to return false? So this false here is once again a Boolean, right? So right now for and, or, and not, which are the logical operators we are going to be covering today. For those, the we're and, or, and not are used to compare logical operators. Very similarly to how comparison operators are used to compare numbers, if that makes sense. So this here, this third line here is printing out whether it is spring break and summer break. Spring break is true, summer break is false. So obviously spring and summer break can't happen at the same time. So it's going to return false. But Danish, once again, just go to Google Colab, just hit the first link, make sure you're logged in, and then hit the new notebook button. Yeah, of course.
Wait, why is
Okay.
the first one false?
Okay, why is the first one false? So true. Okay, so the whole idea of this and here is it wants to see true for both of these, right? If it sees true, if spring break is true and summer break is true, then it's going to return true. So and will look for two booleans. If both of those booleans end up being true, then it's going to print
Oh, wait,
out
I'm
true.
stupid. Yeah.
Yeah, no, you're good. And then print spring break or summer break. It's spring break. And so since it's spring break, it doesn't matter whether summer break is true or false because spring break is already true. It doesn't need to check the second one. But if spring break ends up being false, then it's going to check the second one. And depending on whether summer break is true or false, if it ends up being true, then it's going to be true, right? So once again, for the OR logical operator, it's going to take in two booleans, and regardless of whether one of them is false, if one of them it ends up being true, then it's going to end up returning or printing out true, right? So the only way that OR can be like end up returning false is if both of the values presented with an OR are false. So if it's false or false, that's going to be the only way it can return false. If either of those values end up being true, once again, then it's going to return true. Okay. And then printing not spring break, not is a little more simpler than the other two. It only looks at one variable, one Boolean, right? And depending on whether the Boolean that it's looking at is true or false, it's going to return the opposite of that, if that makes sense. So spring break here is true, right? So not spring break, so not true would be false. Let's take a look. False, true, false. I wanted to do a quick question for you guys. Let's see. I want you guys to tell me what this will print.
In the chat.
Yeah, yep, right in the chat.
Yep, feel free to just put your answer in the chat.
Cool. I'm getting a few correct answers. I think it's going to be true, but let's run it together. It ends up being true. I'm going to go a little bit in depth. 4 equals 6. Is 4 equal to 6? 4 is not equal to 6, unfortunately. So our OR statement is going to look at the second item here, second statement here, and it's going to check whether 6 is greater than 3. 6 is greater than 3. So one of these values is true. One of these values ends up being true. And so the entire logical operator segment is going to return true. Let me do one more, guys. Print. All right. Can you guys help me out here? What does this one do? Yeah, this one's a little bit trickier. So these parentheses here are really similar to just in like math in terms of whatever's inside the parentheses gets kind of figured out first, right? So we're gonna take a look at this parentheses here, this set of parentheses here. Not 3 equals 3. Let's check the comparison operator section first. 3 is equal to 3. Or okay, so the question we have to come up with is 3 equal to 3? 3 does end up equal to being 3. So this is going to be not true. All right, okay, so this section is going to be true, right? And then so since we paired it with the not, that part's going to be false, right? Because not 3 equals 3, that's true. So not true is equal to false, right? Let's check the other section. False or 4 is equal to 4. Is 4 equal to 4? 4 is equal to 4. So the whole thing is true. So technically, we actually didn't need to look at this section here. We could have just looked at the easier one. And if that catches our eye and we're like, hey, that does equal to 4, then we can just kind of or like 4 does equal 4. And then you can just kind of say like, hey, it is correct. So that is true. We'll do an and real quick. Oh, I guess that gave me an answer. It's giving me an answer. Okay. You guys can try this one. Okay. Yeah, this one's much easier. It is false. Because 4 is not equal to 6, and we need both of them to be correct. So if one of them is correct, then uh everything works. Or even if one of them is correct, it still might not work out completely. So yeah, Aaron, you want to take it from here?
Yeah, sure. So I'm gonna go ahead and oh, I don't think I can share while you're screen sharing.
Yeah,
So
I got you.
go ahead and screen share now. So, all right, are you guys able to see my screen? All right, that's
Mm.
great. So, so why do we have to cover Booleans? Why are Booleans so important? Well, there's something called conditional statements in Python, and they are the backbone of basically all of coding, right? Coding is all about logic, and Booleans are logical operators, right? So how do we work with our Boolean values now? We know that there's two Boolean values, true and false, but what do they mean? How can we use them in our programs? Well, let me introduce you to the if statement. So the if statement says that if, and then we're going to put something here, colon, and then we can tell Python to execute something. So I can say like print hello. So what is this thing that we put in after the if? Well, it is our Boolean value. If the Boolean value is true, then it will run. The thing inside of the if block will run. So let's try it out. It's just going to connect for a little bit. Boom, it has run. So what happens if our Boolean value is false? Then nothing will run. So that is how the if statement works. It will run whatever code is inside of it if if the value given here is true. All right, so let me go over the structure one more time. So to start off an if statement, we start with if, and then we're gonna have our Boolean value. So this can even be a variable, right? So for example, if I go up here and I define a variable to be Boolean, and I say Boolean is true, so if Boolean, colon, then your IDE should automatically do this, but when you press return, you should automatically indent. Indenting is really important in Python because that tells Python what level each code is at. So basically, that just tells Python that, okay, the code from now on, the code in this indent is part of the if block. So when you press return, it should automatically indent, but if not, you can just press tab and it will go in one more indent space. But sorry, but I'm just going to press return. It's going to do it automatically. So now we're indented inside of the if block. And let's say that if my Boolean value is true, I want to print Boolean is true. All right, so now let me run this code. And we see that Boolean is true because the value of Boolean is true. I define it up here. So now if I change Boolean to be like 4 equals 4, that will also return true. Why? Because Boolean I define up here is 4 equals 4. And if we go back to what Mohan was teaching us, right? Does 4 equal 4? Well, yes, it does. So that returns true, right? That equals true. So now Boolean is true. And since Boolean is true, we'll go ahead and run the code inside of our if statement. Okay, so Jatin said, wait, so if there is not any value before the if statement, is it defaultly considered true? No, you always have to provide a value for the if statement. If I do nothing, like if I just have it if by itself, Python will complain. It'll say invalid syntax, basically saying that I am not following the rules of Python. So I have to always include something. All right. So you could also have an expression instead of a variable here. So Boolean is a great variable, but I think that's kind of redundant. What if I just say if 4 is equal to 4? I can just have the expression by itself right here. And let's see what happens if I run this code. And it says Boolean is true. So that works as well. So I can have expressions inside of the if on the if statement, right? And this reads basically like English, right? So if we just read it like English, it says if 4 equals 4, then I will print Boolean is true. And that's exactly what it does. So since 4 equals 4, it will print Boolean is true. Okay. And also this would work for a false statement, right? So we could say if 4 equals 5, print Boolean is true. And since that's false, nothing's going to happen. All right, so this is pretty useful, right? So, but what about the false statement? Like the if statement isn't really useful if it's false, right? Or what if we want multiple conditions? Well, there is something called elif. So elif is just basically a condensed form of else and if together. So elif basically just means like it reads just like English, right? So if 4 equals 5, print this thing. Else if, and then I can give another statement. Else if 3 is greater than 8, print a second statement. And I'll just print something out. And the way Python orders its if statements is it'll go in order. It'll first evaluate the first if statement, and it sees that it's not true, so it won't print it. And then it'll go to the next one, and then we'll see that it's not true, so it won't evaluate it. And then maybe we can go to another one. And then finally, it will evaluate the statement, and it will now print out our result. So this is called an if elif else chain. And there's one more thing to add to the if elif else chain, and that is the else. So let's say everything is false. Somehow we got really unlucky and everything happens to be false. Then we can have something called the else block. And the else block will only run if everything above it in the chain is false. So here we go. And we see that we printed everything was false. And that's because all of our other 3 previous if statements were false. So they didn't get evaluated. But I want to point out one important distinction. This is an if elif else chain, right? We see the if, we see the elif, and we see the else. But you know what is not an if elif else chain? This is not an if elif else chain. Let me write it below some hashtags here. This is not an if elif else chain because there is no elif and no else. So remember, this is how I remember it. An if statement always starts an if elif else chain, and an else will always end it. But the else isn't always required. So if we see up here, we have one chain, right? Python will say, okay, I'm just going to go through it one by one, and boom. And the important thing about the if elif else chain is that once something is true, so let's say the second one was true, right? So I'll change it to be true. It will go into the indent and evaluate it, and then stop. It will stop right there. It will not go to any of the other ones. So let's see what happens if I run this. Let me comment this out first. So I'm running this first chain, and this is basically just showing what happens if multiple things are true. What will get evaluated? Well, we see that only the second statement got evaluated. That else was completely ignored. So is the second elif, and so is the first if. So in a chain, only one thing will get evaluated. All right. Only one thing. Well, technically, nothing could be evaluated, right? If you don't have an else statement, nothing could be evaluated. But at most, one thing will be evaluated. because as soon as it enters one of the indents, it will stop. It will exit the block and it will no longer evaluate anything after that. So we see here that our only true statement right now is the second one, right? 3 is less than 8. Now let's see what happens if I make the third statement true as well. I'm going to tell you right now, it's not going to get evaluated. So let's see what happens. And we see that it did not get evaluated. Only the second one got evaluated. So make sure you remember in these blocks, as soon as something is true, it will get evaluated and then it will exit and not evaluate anything after that in the block. So now let me show you what I was talking about before, and that is a bunch of if statements by themselves. These are basically four chains, right? These are basically four if else chains. So that means if they're all true, well, that just basically means that they're not dependent on each other, right? These chains are dependent on each other. These are all independent. The second one will run if it's true, regardless of whether the first one is true or not. So let's see what happens now. So let me comment out this up here so it doesn't interfere with it. At least see what happens now. Boom. 3 things were evaluated. It seems like Python did not break out of any change this time. And that's because they're all independent, right? If always starts a chain, you can basically think of this as 4 independent chains, and they just don't rely on each other. So the first one is saying, okay, if 1 equals 1, I'm going to print high. And 1 equals 1, so it prints high. Then the next one is just going to keep on going. It's not going to skip the rest of them. So that's the difference. And when we use elif, remember, elif means else if. So what does else if mean? It basically means only do this if the first one isn't true, right? Else basically means like the first one wasn't true, right? So else if is like only do this if the first one isn't true and the next statement I'm providing is true. So when you use elif, you are basically constructing a chain. If you only use ifs, Python will just evaluate everything by itself and they're not dependent on each other. Okay. And remember, Python will only go into the if statement's indent if the statement provided is true. Okay, so that's a lot of information. So hopefully you guys aren't too confused, but let me go ahead and give you guys another example. And I want you guys to tell me in chat what this will return. So let's say I have my statement, if
Wait, what are we answering?
so basically you just want to tell me what this will print out, basically.
Okay.
Sorry, I have a pretty bad cough, so so if I have this statement right here, what will it print out? This one is a little tricky, so be sure to take your time, analyze it carefully, and put your answers in the chat. Don't worry if they're wrong. All right, so I'm seeing a lot of answers in the chat, so let's run it and see what happens. Boom. So the first line and the third line have ran. So let's break this down. So Python always starts at the beginning, so let's just go to the beginning, and we see that our statement is if rainy equals rainy, then we're going to print it is raining. Well, rainy equals rainy, right? So that's pretty obvious that it's true, so we're going to print it is raining. Now Python is on the second line. So now Python will see does 7 equal 9? And Python is Python says no, 7 is not equal not to 9. So we're going to skip, or we're not going to evaluate the first one. Now remember, now I want to make this clear. From the second line onwards, we're in a chain, right? So just keep that in mind. So now we're in the elif. So else if 6 divided by 3 equals 2, we're going to print second. Well, 6 divided by 3 is 2, so we're going to print second. And since we're in the chain, we're going to skip everything after that. So we don't even have to look at the else. So that's it. We're going to print it is raining, and we're going to print second. All right, and I don't know if we cover this yet, but you can compare strings in Python. It's the exact same as integers. If you use this double equal operator, it will just compare two strings if they are exactly the same, including capitalization. So if they're the exact same string, including capitalization, then they're obviously equal, and then it will be true. Okay. So now I have a challenge question for you, okay? So I want you guys to tell me what this code does, all right? Don't tell me. So obviously this code is going to output something, but remember the purpose of building programs is to build something that's useful for us to use. So I'm going to write a short program here. I want you guys to just think through it, just look at what the program does, and I want you to tell me the purpose of the program. That's basically it. All right. So we're going to start by saying x equals int input. Please enter a number. All right, so this just asks for a input from the user and converts it to an integer. Then I'm going to go into an if statement. So I'm going to say if x mod 2 equals 0. So I'm going to print. So what does this program do? It might be pretty obvious, right? I think the print statements give it away, but what does this program do? Yep, Tony is right. This program basically just determines whether or not x is even or odd. Now, can you guys see how this program works? This is basically a mini algorithm, and programming is all about algorithms and using logic. So are you guys able to see how this program differentiates between even and odd? Because that's the trick of programming. So if not, that's okay, because this is only day 2, right? And we are still basically just covering syntax. But I will walk through it and I'll explain every step of the program and why it works. So sorry, please excuse my cough, but on the very first line, we have a variable called x, and we're just assigning it to this thing. And basically, we all know that this just asks for an input from the user and then converts it to an integer, right? Because because the purpose of this program is to determine if a number is even or odd. So we obviously want to work with numbers, right? Integers. Then all I have next is my if statement, and it's a block, as you can see. So if one of them is going to be executed, the other one will not be executed. So the first thing is I'm basically checking if the number is even. So an even number when divided by 2 will have 0 remainder, right? Can you guys see that? That's basically a fact for math. That's basically just saying every even number is divisible by 2, right? That's the definition of an even number. So basically, if x mod 2 is 0, then x is even, and I'll print that out. Else, that means if I'm on the else statement, that means x mod 2 was not 0. So it's not even, which means it's odd. So that's why I'm going to print out that it is odd. All right. So that will wrap up our class today. So if you guys have any questions, feel free to ask them right now and we'll answer them as to the best of our ability.
do you want us to submit the homework? Like, do you want like us to like share it from like Google Drive or something?
Um, I believe that in Classroom you should be able to attach a Google Drive file. So yeah, I think if you just attach the Google Drive file, um, I think we can see it and we can
When
grade
I
it.
try to do it, it says it's when I try to like go to the drive, it says it's like an unsupported file type.
Really, and that's very interesting. Okay. Um, okay. You if nothing else works, you could email it to metexcellence@gmail.com and we can look at it there.
Okay.
But hopefully I will be able to fix this and you should be able to submit it normally. All right, so are there any other questions? Everyone understanding Booleans, okay, and if statements?
Yeah.
All right, that's great. Then it's 9 o'clock now, so you guys are free to leave. Thank you for coming. Jatine or Caitlin, do you
Thank
guys?
you.
Thank
Huh?
you.
All right, thank you. Bye.
Okay.
That was good.
Yeah, that
Yeah.
was good. Let me stop my recording here.